Okay, hello distance learners. It's September 17th. We're starting new things for the day. Okay, family, calendar, yes? Today we did quiz 3 on two-way tables. Remember that your quiz 1 retake, if you want to do that, is due tomorrow. You can come take it during lunch or after school. You don't have to come in tomorrow. And if you need a different accommodation, just let me know. Yes? Okay, homework for Friday. Just kidding. Homework for today. I need you to watch the videos, and I'm going to put this in Canvas as homework. Yes? So you're going to log in. It'll be the top module, and it'll say homework for 9/17. There will be 3 videos. You have a dot plot video. That'll go way fast. It'll be 5 minutes or less probably. A histogram video, that's going to be horrible. Brace yourself. And then a STEM plot video. That one's going to be just fine. Histograms, not going to be a party. But all the other ones going to be easy, okay? You need your calculator for the histograms. So make sure that when you start that one, you're ready to go. Then on your can you do, and then you need to do your can you do number 2. Because it has the post-it with the little shoe on it. Yeah? I need you to count up your shoes, but not flip-flops. Not flip-flops. We're not going to count flip-flops. But count up how many shoes you have, and then I'm going to get this post-it from you next time so that we can make a graph out of it. Are there any questions on that? This might take like an hour and a half just to prep you. Yes?
And when you say count shoes, you want a pair of shoes or individual?
Pairs of shoes. Numbers of pairs of shoes. Yes.
Your shoes or your entire family's shoes?
Just your shoes. Just your shoes. Abby.
Okay, this is a really dumb question, but like when you say flip-flops, you mean like sandals included?
Like you went to Old Navy and bought $1 flip-flop. Those don't count.
Oh.
But if you got some cute sandal that you wear to school, yeah, count it. Because my sister owns like 38 pairs of flip-flops. Those don't count, okay? Just because you have it in every color. No. Cover your toes. All right? Okay. You're good? All right. So the only thing that we have left to do in class today is this expected counts packet. I love expected counts. It's on the very back. It's not a packet. I don't know why I said it's a packet. It's just one page. It's on the very back of two-way tables. Is this 6 or is this 5? This is 5, right? This is our 5th packet. No, the dot plots are 6th, isn't it? Yeah, two-way tables is 5. The dot plot is 6. And then I think I'm going to start numbering them for you. Okay, so the whole point of this two-way lesson, two-way tables business, is we want to be able to see if there is a relationship between 2 variables. So first we learn how to use a two-way table. Then we talk about marginal distribution so we can get an overall picture of the data. And then it goes crazy town, and we talk about how we can look at conditional distributions to decide if there is a relationship between 2 variables. So we go in, and all of a sudden, you got to find 1 billion %, and you got to make a segmented bar graph. Before your quiz, I was telling you that if there is not a relationship between 2 variables, the number that you see in the table, or the percents, I should say, not the numbers, the percents that you see in the table will be what? The exact same. So we're going to use that idea to see if two variables have a relationship. So another way to determine if two categorical variables are independent, I-N-D-E-P-E-N-D-E-N-T, shiz, Macklemore, is to use the expected value formula. I'm going to highlight that. To determine if what you expected to happen is the same as what actually happened. So if two things are independent, what we expect to happen is that the percentages in the table are going to be exactly the same. So we can use this formula to go in and see, are those percentages going to be exactly the same? So this is your formula right here. You can ignore this top sentence. Don't kill it. Just, you don't have to know it right now. But I'm going to write a little note that says this only works. This only works when two, that's not how you spell when, when two variables are independent. This only works if there is no relationship between the two variables. Okay. Below is data on gender and body image. Do we think that there's going to be a relationship between those two things? Do you think girls are going to feel differently about their bodies than boys do? Probably, because the expectations for the different genders are different. So a random sample was asked how they view their body size. The responses are below, so these are our responses. Use the second table to calculate what was expected to happen. If the variables are independent, the two tables will have the same values. So these are the actual responses. This is what the kids actually said. What is the explanatory variable? Gender. So one way to think about the explanatory variable is, will one change the other? So will the way you feel about your body change your gender? Probably not. Now, as I was walking around during your quiz, I almost stopped you guys to help you, because is your superpower preference going to change where you live? No. The explanatory variable on your quiz was where you live. That might influence what your superpower preference is. Your superpower preference has no influence on where you live, unless you like a diehard fan and Superman is from like Bolivia. Maybe you might move to Bolivia. Tierra. Okay, she's not having it. So the explanatory variable here, we think that our gender is going to have some influence on our body image. That's not required. I just want to use this as an opportunity to investigate that. Okay, well, we're going to use this table to calculate what is expected. This is what is expected if independent. If you have GTI, just skip to 9 minutes in the video and you'll go right to this. Okay, so here's how we calculate this. If these two things are independent, Let's find out the number of females that should have responded that they feel about right about their body. So up here, our formula tells us, take your row total. So there are 760 females. You multiply it by your column total. 855 people said that they feel about right. You divide that by your table total, 1,200. You plug that into your calculator, and I believe it gives you 541.5. Is that true? If these are expected to be independent, if gender has no influence on how you feel about your body, we expect 541 and half a person to have said, or females to have said they feel about right. What actually happened? 560. So right there, I don't even need to finish calculating the table. These two things have a relationship. If they had no relationship, this 560 would have equaled 560 here, but it didn't. Is that making a little bit of sense? Okay, let's find the number for overweight. So same thing, you use your row total, 760, multiplied by your column total. This time it's 235. Divided by your table total, 1,200. What do you guys get that time? 148.8. If these two variables are independent, I would expect about 148 females to say they feel overweight. 163 actually did, so these two things have a relationship. Okay, you find the underweight, and I'm going to pull somebody's stick to tell me what it is. So you calculate underweight for the female. And if you're already done, finish the whole table, and I'll pull a few sticks. Give you about a minute. Really calculate it. About 30. $20. $10. Okay, Ella, what did you get for female and underweight? 69.7. Emmy learns from home. Emmy, what did you get? Just kidding. Hopefully you know, though. Ty, what did you get for male and about right?
I'm working on that right now.
Okay, I'll come back. Daniel, what did you get for male and overweight?
I haven't got there yet.
Daniel. Okay, I'll come back. Danica, did you get to male and underweight? Oh, dang, Gina. What'd you get? 40 point. I got 40.4. Did I round wrong?
Yeah.
Oh, darn. Okay, Ty or Daniel, let me know when you have yours. Okay, Ty's male and about right.
I got 313.5.
Great. What's yours?
86.2.
Perfect. So you don't have to go through and complete the whole table to show that these have a relationship. You could have just calculated one value, but now that we've done it, you can see that none of the inside values are the same. So there definitely is a relationship. So let's just fill out this bottom part. Don't start cleaning up. We'll have plenty of time, I promise. Gender and body image are not independent. The expected values and the actual values are not equal. And we mean exactly equal. So there is an association, which is just fancy for relationship, between gender and body image. So if we went through and calculated the conditional percents for this table, what you would find, don't start cleaning up, is that men are more likely to feel like they are underweight and women are more likely to feel like they are overweight, which makes sense to me. Does it make sense to you? Okay, everybody very quickly do the split ticket. It'll take like 30 seconds. A split ticket is a voting pattern in which a voter casts votes for candidates from more than one political party. In a recent study, 1,000 men and women were asked whether they voted a split ticket in the last election. The totals are shown in the table. What value of A would indicate no association between gender and voting pattern? So you're looking for A. See if you can find it real quick, and then we'll clean up. You are looking for A. I'll pull one stick. Then we're done. $20, $10, $3. Victoria, what'd you get? I got 480. Double check yours. I bet you just pressed the wrong button. Once you get 480, you may clean up. Please do your homework. Oh, guess I can stop the video for distance learners. Okay, goodbye, distance learners. Hope you have a good day.